Now, we shall solve this problem. Here, if the straight line x cos theta plus y sin theta equal to p is a normal to the hyperbola whose equation is x square over a square minus y square over b square equal to 1. Then we have to show that p square into a square sec square theta minus b square cosec square theta equal to a square plus b square to the power 2. Here, the straight line x cos theta plus y sin theta equal to p is a normal to a curve. This curve is hyperbola whose equation is x square over a square minus y square over b square equal to 1. We have to prove that the p square into a square sec square theta, also a square sec square theta, a square sec square theta minus b square cosec square theta equal to a square plus b square to the power 2. Let us begin. Before the solution of this problem, we have to know about the normal. What is normal? Normal is also a straight line which is perpendicular to the tangent to a curve at the point of contact. A straight line is called normal to the curve if this straight line is perpendicular to the tangent to this curve at the point of contact. Then this line is called normal. Here x cos theta plus y sin theta equal to p is the normal to the curve this which is parabola. This is the equation. This equation is given as the normal to this hyperbola. Now, if we choose x1 y1 be the point of contact at which tangent is drawn. This is the point of contact and the coordinate of the point of contact is chosen as x1 y1. Now, we have already known the equation of tangent to any curve at x1 y1, that is at point of contact. At point of contact, the tangent equation of tangent is y minus y1 equal to dy dx at the point x1 y1 into x minus x1. That is the gradient of the tangent is dy dx at x1 y1. Value of the gradient of the tangent is equal to the dy dx at x1 y1. This is the geometrical significance of dy dx. Dy dx is nothing but the gradient of the tangent at any point x1 y1. So, the gradient of tangent is dy dx at the point x1 y1. This is the gradient of the tangent. Now, normal is perpendicular to the tangent. Normal is perpendicular to the tangent. Normal and tangent are mutually perpendicular. So, gradient of normal is also the negative reciprocal of the dy dx at x1 y1. That is the negative reciprocal of the gradient of the tangent, because tangent and normal are mutually perpendicular. So, the product of their gradients is minus 1. So, gradient of normal is equal to the negative reciprocal of the gradient of the tangent. So, gradient of the normal is equal to minus a negative reciprocal, that is minus 1 over dy dx at x1 y1. So the equation of normal, so the equation of the normal at x1 y1 is equation of straight line is y minus y1. Normal is a straight line, so equation of normal is y minus y1 into gradient. Gradient of normal is this, that is minus 1 over dy dx at x1 y1 into x minus x1. Also we can find out the dy dx at x1 y1 from this curve. The equation of curve is x square over a square y square over b square equal to 1 minus 1, a minus x square over a square minus y square over b square equal to 1. We can differentiate both sides of this equation of the curve with respect to x. We get, and then we get 2x over a square minus 2y over b square dy dx equal to 0. So dy dx equal to b square x over a square y, and also value of dy dx at x1 y1 equal to b square x1 over a square y1. This is the value of dy dx at x1 y1. So equation of normal is y minus y1 equal to minus 1 over b square x1 over a square y1 into x minus x1. So a square, if we simplify this equation, we get a square b square a square y1 into x plus b square x1 into y equal to a square plus b square into x1 y1. After simplifying this equation, we get a square y1 into x, b square x1 into y equal to a square plus b square x1 y1. This is the equation of the normal, and this equation and this equation are the same equation, that is these two equations are the equation of the same normal. So a square y1 plus b square x1 y equal to these two equations are the equation of same normal, These two equations are the equation of same normal. So these two equations are identical, because these two equations are the equation of the same normal. So these two equations are identical. So these are identical because these two equations are the equation of the same normal. So these are identical. As these two equations are identical, so the ratio of the coefficient of x equal to the ratio of the coefficient of y equal to ratio of the constant terms. So, we can write a square y 1 over cos theta equal to b square y 1 b square x 1 over sin theta equal to a square plus b square into x 1 y 1 over p. So, we can get the value of x 1 y 1 from these equations. From this equation, if we consider first and third term, then a square y 1 over cos theta, first ratio, considering first ratio and third ratio, that is a square y 1 equal to a square over p, which implies x 1 equal to value of x 1 equal to a square p over cos theta into a square plus b square. Similarly, if we consider the second and third ratio, we get b square x 1 over sin theta equal to a square plus b square into x 1 y 1 over p, which also implies y 1 equal to, we can get the value of y 1 equal to b square p over sin theta into a square plus b square. So, we have got the value of x 1 y 1, that is the coordinate of point of contact. Coordinate, so coordinate of point of contact, that is x 1 y 1 equal to a square p over cos theta into a square plus b square b square p over sin theta into a square plus b square. This is the coordinate of point of contact. This is the point of contact. This is the coordinate of point of contact, and also the point of contact lies on the curve. Point of contact also is on the curve, that is, this curve is hyperbola, that is the point of contact x 1 y 1 must satisfy the equation of the hyperbola, because the point of contact lies on this curve, that is hyperbola. So, x 1 y 1 satisfies this equation. So, we can write x 1 square over a square minus y 1 square over b square equal to 1, which implies, if we put the value of x 1 y 1 in this equation, we get a 4 p square over cos square theta into a square plus b square whole square minus b4 p square over sin square theta into a square plus b square whole square equal to 1, which implies also here a square into a square into b square. The denominator includes a square and denominator of this term includes b square. So, this is equal to 1. So, I can write a square sec square theta p square minus p square b square cosec square theta equal to a square plus b square whole to the power 2. So, we can write p square into a square sec square theta minus b square cosec square theta equal to a square plus b square whole to the power 2. Whole to the power 2. This is the result. So, we have got the result, that is, we have proved this result, this equation, this relation. This relation is proved when the line x cos theta plus y sin theta equal to p is a normal to the hyperbola x square over a square minus y square over b square equal to 1. Thus, we have proved this relation.